And we're live. Hello, everyone, and welcome to World Oceans Day. Happy World Oceans Day to everyone. This is Exploring by the Seat of Your Pants, and my name is Melissa, and I'm going to be your host for today. We have a guest with us, Hilary Moors-Murphy, and she studies whales off of the coast. This is Exploring by the Seat of Your Pants. Yes, my name is Melissa. I'm going to be your host for today. We have a guest with us, Hilary Moors-Murphy. Oh, I'm sorry, guys. She studies whales. Okay, there we go. I had some feedback going. So we're going to talk today with Hilary about her studies. She works for Fisheries and Oceans Canada on the East Coast. She received her Ph.D. in biology from Dalhousie University, and she listens for the acoustic calls of whales and other marine mammals, and she's hoping to help with the important role of conservation and protection of our marine mammals on the East Coast. So with that, I'll hand it over to Hilary. Hilary, welcome.
Thank you very much. And first off, happy World Oceans Day, everybody. I'm just going to pull up a presentation that I put together, and then you're going to hear a little bit about my research and also get to listen to some whale sounds. Okay, so I should be sharing my screen now. And can everyone see my slide?
I can see it. I think all of our classes can see it.
Excellent. So I'll get started. Hello, and thank you for hanging out with me today. As you have heard, my name is Hilary Moors-Murphy, and I am a research scientist at Fisheries and Oceans Canada. And as part of my job, I help research and monitor whale species off Eastern Canada. And my main research focus involves passive acoustic monitoring or listening to whales. So I thought I'd start out today with just a little bit about me. So when I was very young, even much younger than I am now, I always loved the ocean, and I especially loved whales. So I decided that I wanted to try to study them when I was in high school. So I went to university to do a Bachelor of Science degree majoring in marine biology at the University of New Brunswick, St. John. And there I met Dr. Jack Terhune, who introduced me to the wonderful world of marine mammal sounds. So under the supervision of Dr. Terhune, I completed first an honors project and then a Master of Science degree in biology studying harp and Weddell seal sounds. So these are seals that breed on the ice, and we would put recorders under the water and record their sounds, and then I would study those sounds. I then went on to do a Ph.D. at Dalhousie University in Halifax, Nova Scotia, under the supervision of Dr. Hal Whitehead. And there I spent much time at sea on board the lab research vessel, which was a 40-foot sailboat called Balena. And I was able to study whales up close and personal on the sailboat. I spent most of my time studying northern bottlenose whale sounds off of Nova Scotia. So my research on northern bottlenose whales led me to work with Fisheries and Oceans Canada at the Bedford Institute of Oceanography in Halifax, where I am still working today. So what do I do there? Well, I study whales off of Nova Scotia. Did you know that there are more than 20 different species of whales, dolphins, porpoises, and seals that regularly occur off Eastern Canada? So just to give you a few examples, with less than 550 individuals left in the population, North Atlantic right whales are one of the most highly endangered large whale species on Earth. This 15-meter long whale, which is just a little bit longer than the average size of a school bus, visits waters off Nova Scotia and Eastern Canada every summer and fall to feed. This is one of the whale species that are a focus of my current research program. I also study blue whales, which are the largest animal to have ever lived on Earth. growing up to 30 meters in length, which is roughly the length of 2.5 school buses. The North Atlantic blue whale, found in eastern Canadian waters, numbers in the few hundreds, and these are also considered an endangered species. They are another migratory whale species that occurs in waters off Nova Scotia every spring, summer, and fall. And of course, I'm still studying northern bottlenose whales, which is a species I studied during my Ph.D. at Dalhousie. Northern bottlenose whales are a strange and mysterious whale species found in deep waters offshore of Nova Scotia. These whales are large animals growing up to 9 or 10 meters in length, and they undergo long, deep dives of over 1,000 meters that can last for more than an hour to feed on deep water squid. The bottlenose whale population in Nova Scotia waters consists of about 140 individuals and is also considered an endangered population. These animals remain in Nova Scotia waters all year round. And there are a variety of other marine mammal species that use our waters either year-round or seasonally. And my research lab is interested in many of these other species as well. Fisheries and Oceans is responsible for management and protection of these marine mammals in Canadian waters. Surprisingly, we don't actually know a lot of the details about the distribution and abundance of many of these species off eastern Canada and off Nova Scotia in particular. And this is in part due to the fact that the visual studies in the Northwest Atlantic can be logistically difficult, particularly during the winter months. So it's not always pleasant to be out at sea, and it's not always easy to see whales when you're out there. Another way to study when and where whales occur is through passive acoustic monitoring, or for listening for their sounds. So whales and dolphins use underwater sounds to communicate and feed. Many whales and dolphins in eastern Canadian waters are vocal species that produce really distinctive underwater sounds. And this means that we can tell species apart by the different sounds or calls that they make. We can learn a lot about when and where these different species occur, and even potentially what they are doing when they are there, just by listening for their sounds. And this basic information on when and where whales and dolphins occur throughout the year is needed to understand and accurately assess potential threats to individuals and populations. The main objective of my research program at Fisheries and Oceans is to better understand how whales and dolphins use our waters throughout the year using passive acoustic monitoring. Underwater sounds made by whales, dolphins, and porpoises can be recorded using a hydrophone. And a hydrophone is a fancy word for basically a waterproof microphone that is designed to listen and record underwater sounds.
Oh, Tyler. I'm gonna go close the blinds.
Now unmute. Hi, we wanted to talk to you. Can you guys hear us?
No, they can definitely hear us.
They can hear us, but
Are you sure? You gotta unmute yourself. Hi.
Bye.
We wanted to know what grade you're in.
4.
Where are you from? You guys are too loud. Canada?
We are from Barrie, Ontario.
Yeah. We're from Brampton.
We are ninth graders in New Jersey.
We're still trying to get back in. Oh.
What happened here?
So also we might be waiting for the biologist. Or the
Okay, yeah, we're completely gone. Well, that's disappointing. No, I mean, they're there. The lady who's leaving it is gone. Oh, wait, she's back.
Hello. Hello.
Hi, Hilary. We can hear and see you.
Okay. Did you actually see my presentation?
We saw up until kind of the end of your undergraduate and graduate and kind of the start of your career.
Oh no, that's terrible. So I can't tell when I'm sharing my screen what's going on in the background.
Yeah.
But I'm not sure. It's sort of like you cut out, and then everybody else kind of disappeared too.
Yeah, I think most of us are back and good to go. So if you want to start sharing your screen again, we'll keep going.
Okay, my apologies.
No worries. This happens.
Let's see. Why don't we jump into studying whales?
Okay.
Okay, so you can still see and hear me right now, or sorry, you can still see my screen.
So far, so good.
Okay, and I can't tell if I'm sharing my screen right now.
Not yet.
Okay.
There we go.
Okay, and everybody's still online?
Awesome.
Okay, so after I completed my studies at Dalhousie University on northern bottlenose whales, that led me to work with Fisheries and Oceans Canada at the Bedford Institute of Oceanography in Halifax, where I am still working today. So what do I do there? I study whales off Nova Scotia.
Okay. So I guess we're.
So we have,
dolphins.
hello?
Sorry, Hilary. I have a message from Claire's class that we actually saw past dolphins. So I must have cut out a little bit before everyone else.
So, trying to figure out where most people saw. Did they see when I started talking about passive acoustics?
Oh, we have some. Slide 26.
Okay, good. We got through most of it.
Okay. Oh, Miss Cathcart's class said they didn't see any of it. Oh my goodness. Okay, so maybe. Yeah, I think if you want to show the whale sounds, I think that would be a good start. Wherever.
Okay. So perhaps I'll give sort of the quick version. And the quick version is that Fisheries and Oceans is responsible for management and protection of whales in our Canadian waters.
Oh no, the screen has gone black. Oh, there it is. It's presenting.
Okay, so we don't know a lot about the distribution and abundance of many of these whale and dolphin species off eastern Canada, and that's in part due to the difficulty in studying these different species. So it can be really logistically difficult to study whales at sea, particularly when it's not summertime. So we have a lot of difficult weather off of Nova Scotia in particular. And so an alternative method to studying them, and alternative to visual studies, is to use passive acoustic monitoring. And passive acoustic monitoring is essentially listening for whale sounds. So are we all still there?
Is everyone, can they hear? Thumbs up if you can hear. Awesome, thanks guys.
Okay. So whales and dolphins, they use underwater sounds to both communicate and feed. And many of the whales and dolphins in eastern Canadian waters are very vocal species that produce distinctive underwater sounds. We can learn a lot about when and where whales and dolphins occur, and even potentially what they are doing by listening for their sounds. So basic information on when and where various species occur, and even potentially what they are doing there, is required to understand and accurately assess potential threats to individuals and populations.
Okay, I think we're back in.
Yes.
Okay, so just checking in, is everyone still on there?
Thumbs up if it's still good on your end, guys.
Great. So the main objective of my research is to better understand how whales and dolphins use our waters throughout the year using passive acoustic monitoring or by listening for them. So I do this using a specialized piece of equipment called a hydrophone. And a hydrophone is essentially a microphone that is waterproofed and designed to listen to and record sounds underwater. Hydrophones come in many different shapes and sizes. So some of them can be an over-the-side hydrophone, so a really small system that you can lower over the side of a boat by hand. However, the systems that I use the most are these types of hydrophones that are known as autonomous multi-channel acoustic recorders, or we like to call them AMARs for short. And these recorders are designed to sit on the bottom of the ocean and record sounds for months to even a year or so at a time. And this is an image of what the AMAR looks like when I deploy it. And you have flotation at the top that holds the whole system upright in the water. Then there's a long cable with the AMAR attached to it, and that's what records the sounds. And then below that, there's another set of floats that are attached to an acoustic release. And that's the piece of equipment that allows itself to release from the bottom of the ocean. And then that's attached to an anchor. And in the case of my system here, the anchor is a large iron train wheel that sits on the bottom of the ocean. So AMAR deployment involves going to the area that we're interested in studying and lowering the system over the side of the...
Uh-oh. I think Hilary dropped out again. I think We'll message her and let her know, and then she can come back. And send her a quick message. So sorry, guys, about our technical difficulties this morning. All right. Okay, so we sent Hilary a message. Okay, guys, we're just waiting on Hilary to come back in. So sorry for all the technical difficulties today. Thank you guys for your patience. Hi, Hilary. Oh, bye, Hilary. Hello, Hilary. Hi.
Sorry, I don't know what's going on.
Oh my goodness, it's the internet, I think. So we saw some of your AMAR systems on your slides.
Okay. So basically what happens is I bring these AMARs that record sounds for a year at a time. I'll bring those back to the lab, and I'll download the data and analyze the data for the presence of whale calls. So the last thing I wanted to show you was what this actually looks like and to play a couple of sounds for you. So I will attempt once again to share a screen, but I'll go this time to my software that I use to analyze calls. Okay, so right now you should see sort of a purplish yellow diagram.
Yep, we see it.
Okay, perfect. So this is a program called SpectraPlotter, and it's developed by Jasco Applied Sciences, which is a company here in Halifax, Nova Scotia. And it basically allows us to look at sound. And on the top, you'll see a graph called a waveform. And a waveform shows time on the x-axis, and then on the y-axis is loudness. So in this particular sound, you can see there's three main pieces where the sound gets louder. There's the second piece, and there's the third piece. On the bottom graph, it's called a spectrogram. And again, time is on the x-axis, but on the y-axis is frequency. So if something's lower frequency, it's brighter near the bottom, and if something's higher frequency, you'll see it up near the top. So this particular sound, it's more low frequency, so most of the loud parts of the sound are near the bottom, and you can tell the loudness in this diagram by the color pattern. So things that are louder will show up white or yellow, and things that are quieter will be more black or darker purple. Okay, so I'm going to play this example sound, and you can let me know if you can hear it. And you can follow along with this line will sort of play as the sound plays. So here's what it looks like.
Whales are cool.
So did everyone hear that?
We have some thumbs up. We got some thumbs up from Miss Alette's class.
Excellent. Okay, so now we're going to get on to the fun stuff, which is actually listen to some whale sounds. So I'm going to close this file, and I'm going to open a different file. And the file that we're going to listen to next are North Atlantic right whales. So if you remember, North Atlantic right whales are that endangered large whale species that use our waters here off Nova Scotia every spring, summer, and fall. And they produce a very stereotypical sound called an upcall when they're in an area. And this is thought to be a contact call meant for individuals to sort of keep in touch with each other when they're in an area. And so when we're analyzing recordings for the presence of North Atlantic right whales, we'll look for upcalls. So I'll kind of play what this sounds like for you as soon as it loads up here. Okay. So that was a faint one. The next one is louder, like you can see. And then there's going to be another one coming up here. Okay, did everyone hear that?
Oh, I think one class did and one class didn't.
Oh no, so I'll play it one more time. So here I'm actually going to zoom in on that up call, that loud one. Okay, and we'll play it again. And you'll hear it's called an up call because it goes up in frequency. So it goes whoop. Did everyone hear that one?
I think we got some more people who heard it that time.
Okay, so the next call I'm going to play you is something that people are a little bit more familiar with, and that is humpback whale sounds. So humpback whales make these beautiful songs, and we actually record them singing off of Nova Scotia every winter. So I'll play you an example of just part of a humpback whale song. You should be able to hear it. So humpback whales, they also make sounds that are low in frequency, but they're a bit higher than the right whale. And I'll play one more little section here. Okay, so how are we doing now? Is everyone still there? Still here? Okay, I'm going to play some a much higher frequency sound, and I'm going to play some sperm whale clicks for you folks. So sperm whales also occur off of Nova Scotia, and like northern bottlenose whale, they're a very deep diver, and they often undergo these long, very deep dives hunting for deep underwater squid. And these are some of their hunting clicks that I've recorded off of Nova Scotia. So that was a small group of sperm whales that have dove under and are looking for squid underwater using echolocation. And those are their echolocation clicks. And then the final sound that I'll play for you today are some dolphin sounds. So we actually have a number of different dolphin species that occur in our waters off of Nova Scotia. And these sounds were recorded from a species known as Atlantic white-sided dolphins. And like sperm whales, dolphins also click, but they click a lot faster than sperm whales. And they will also whistle. So in this sound example, you should hear some snapping sounds, which are their echolocation clicks. And these clicks occur so fast that they often even sound like buzzes, like a bzz sound. And then you'll also hear a whistle. So this little yellow squiggly line is actually a dolphin whistle as well. So those are some example dolphin sounds. So with that, I'm going to jump back here and I'm going to stop sharing my screen. And I guess if there are any questions.
Yeah, we have about 1 or 2 minutes for questions. Are there any classrooms who want to, I guess we'll start. I can see Miss Ouellette's class. I've unmuted your microphone. Do you have any questions?
Can we protect whales?
Sorry, can you repeat that question?
How can we protect whales?
I always like to say that one of the best ways we can protect whales is to protect our oceans. So anything we can do to help protect our oceans will help whales as well. So we should make sure we're not polluting our oceans and learn as much as you can about the whales as well and let people know about them. So letting people know about these wonderful creatures and making them want to protect them too and to protect our oceans is a great way to protect whales. So healthy oceans will help us have healthy whales.
Awesome. Miss Cathcart's class, would you like to ask a question? Oh, we can't hear you.
So we can't hear you right now.
Okay. There's Miss Cathcart. Right. Do whales communicate with other animals?
Oh, that's a really great question and a very interesting one too. I am sure that other things that are in the ocean that can hear some of these whale sounds that are being made. But as far as we know, we don't think that whales are communicating with other kinds of species, or we don't have direct evidence of that. But I am sure that if there's a seal in an area and the whale is making a call, that those seals can probably hear that sound. But it doesn't necessarily mean that the whales are actually talking to the seals. So we know the whales talk to each other. Not so sure if they're talking to the other animals.
Awesome. And so really quickly, Miss Segretto's class, do you have a question?
Yes. Okay. Hi.
Hi.
Okay, Emily, go ahead.
Do you study belugas? And if you do, what sounds do they make?
Well, I don't study belugas myself, but I know some things about beluga sounds because belugas make a lot of underwater sounds. And in fact, they make so many underwater sounds, they're often called the canary of the sea. So they're a very vocal species, and they make all kinds of whistles and chirping sounds and squeals. So belugas do sound a little bit like birds, and that's why we call them the canaries of the sea.
Nice. And one more question really quickly. We're right at the last minute. So are there any gender differences that you can notice that you can identify based on the sounds you hear from Miss Eng's class?
Oh, that's a really great question, actually. And I will say that in some species, we've been able to attribute a particular kind of call to a particular gender. So a good example is that with the North Atlantic right whale, those upcalls that I played, they're made by both males and females, but there's another kind of North Atlantic right whale called a gunshot, and it's a really loud banging sound, and it's actually thought that that's made by males and associate it with male, maybe an aggression behavior or some kind of competitive behavior. So if you hear gunshots, right whale gunshots on your recording, we often think that that means there's a male in the area because it seems to be only males make those sounds. The other sound I played for you that is a gender-specific sound are actually the humpback whale songs. So those songs made by humpback whales, they're made by male humpback whales. And they are singing, and it usually is thought to have something to do with finding a mate or attracting a mate. So those are a male-specific sound as well.
Awesome. Well, thank you so much, Hilary, and thank you to all our classes who participated and who are watching live. We hope that you enjoy the rest of World Oceans Day, and we thank you for joining us on Exploring by the Seat of Your Pants.
Thank you. Happy World Oceans Day.
Bye, guys.